So the global diversity of can you hear me?
Yes.
The global diversity of the urban forest within the built environment includes trees in a variety of contexts: traditional forest, open landscape, and, more often than not, isolated plantings. Almost all the trees we have planted into those open landscapes and isolated planting locations originate in a forest somewhere in the world. Urban tolerant forest trees that still retain their forest ecosystem genetic capacity. In other words, you can take the tree out of the forest, but you can never take the forest out of the tree. Instead of their forest associates, their forest family coexisting in an environment that enables their genetic capacity, urbanites have decided we want to put these forest trees into our urbanized landscapes, not the way they were before, not the way they have evolved to exist, but according to our needs and our designs, along with new and very improbable associates, a unique non-forest assemblage of flora, fauna, sort of soil, and humans with all our stuff. What all of this has instigated is the practice of urban forestry with its goal: the sustainable management of that forestry in all of its non-forest contexts. Urban forestry has evolved with our need to have nature in places where nature no longer has a presence. So, given that, what tools do we have to meet the dynamic challenges of planning and managing the urban tree resource, and to address the paradox between accommodating the needs of one and the demands of the other? One of these tools is iTree Echo, and the most critical iTree Echo message for urban forest managers is the imperative to grow large canopy trees well into maturity. How we take that message and get it into the ground is both an art and a science, and it's the art that makes the science live. Nowhere is that art aspect of our practice more evident than in working with already done impacts. Finding out what transpired, what it has impacted, and what can be done to mitigate the result demands that we explore and exploit everything that we have collected in our own urban forest management toolbox of creative strategies and experience. The Swiss-wide BAFU-funded iTree project, which is focused on developing and implementing climate change adaptations, and of which I am a co-leader, required that each of our 8 city and canton partners develop 2 products that reflect communication of iTree outputs, as well as applying what we have learned from those outputs. In other words, turning outputs into outcomes. For Lucern's applying what we have learned component, I suggested that we could realize iTree's message through the restoration of the declining Tilia platyphyllos that occupies a heavily impacted space between Luzern's Schweizerhofquai and the Lake Lucerne Promenade. Tilia platyphyllos can live 1,000+ years. This 140-year-old Tilia platyphyllos is protected by Lucern's laws and has a very prominent location in downtown Lucerne, visible from many vantage points around the lake, its crown reaching skywards, well above the surrounding Aesculus trees. Starting in 2008, this protected tilia, along with its soil associate, were invaded and severely damaged by construction and degraded through the installation of gas lines, electric lines, water lines, a sewage outlet from a docked tourist boat, and an advertisement kiosk, all within the footprint of its critical root zone, the area of roots a tree cannot live without. Needless to say, excuse me, it's in decline. There is an extensive dieback in the crown, and as a result of pruning cuts made during all of this rhizosphere stress, it now has a saprophytic fungal disease in a section of the crown. All of this is a result of what these installations did to the structure and fine roots of this tree, combined with turning the soil into an entirely compacted, impervious surface, complete with standing water, tire tracks, etc. This tree has been mismanaged into its decline. I designed a soil restoration and root invigoration program to try to restore the health of this large canopy tree by directly addressing the soil root issues combined with a yearly iTree echo assessment to evaluate and quantify the outcomes in ecosystem services terms. The project, as designed, was completely accepted and is well underway. The soil restoration treatment had two phases. Phase one began with the removal of all the geotextile fabric and, using pneumatic excavation, removal of the compacted stone substrate from the entire area within the crown footprint. This material was replaced with a pH 7 soil with 7% compost by volume. And on top of this, the placement of 5 centimeters of pH 7 compost, vertically incorporated down into the original still compacted substrate. It is essential to get the compost along with the newly added soil down into the uppermost layer of original compacted material. A 2 or 3-pronged fork will open entry points for the compost and new soil into that compacted material, adding nutrients and living soil organisms to begin the process of rebuilding what is already there. The entire open soil area was then thoroughly drenched with freshly brewed compost tea, top dressed with an application of 7.5 centimeters of composted wood chip mulch, and then deep watered in. Watering will continue on a weekly basis if there has not been an adequate rainfall. To address the saprophytic fungal disease, compost tea was sprayed on all the branches that had fruiting bodies to treat the fungal problem in the crown. This eliminates the use of chemicals that are a death sentence to all the pollinators that Tilia hosts and has been used successfully in the treatment of fungal disease. The initial step of opening the soil and reintroducing living organisms was followed 2 months later by phase 2, radial trenching, a pneumatic excavation procedure that is used to mitigate severe compaction issues. After removing the mulch layer and laying out the trench detail, trenches 12 centimeters wide and 50 to 60 deep were created using pneumatic excavation. Exposed roots were then protected with soaked burlap, followed by a compost tea soil drench applied directly into the trenches. And the trenches were then backfilled with the same soil mixture as in phase 1, followed again by a compost tea soil drench for the entire open soil area, the reinstallation of the 7.5 centimeters of mulch, and a thorough watering in. Protection and communication are being implemented as follows. A permanent protection fence installation designed and approved for this highly visible historic site. The fence serves two purposes: reducing the possibility of recompaction, giving the soil a chance to return to life and roots to regain their function, and protecting the public by removing their access to the tree's crown. Posters are being designed to engage the public and to tell the story of Luzern's Lindenbaum, folklore and healing qualities, what this tree has witnessed these 140 years, what it has suffered during the last 13 plus years, what we are doing to try to restore and extend the tree's life, and why. Using a yearly iTree Echo assessment to explain why mature canopy trees are so important to all our well-being. And while there are many things our trees do for us that are not quantifiable, one can use what we do know and we can document to extrapolate additional benefits. Using iTree Echo to not only instigate such projects and communicate the critical relevance of our trees to society's well-being, but to also determine outcomes of such initiatives speaks to another way in which iTree Echo can be creatively incorporated into our urban forest management toolbox. Thanks very much for your kind attention.
Thank you very much, Naomi, also for this nice presentation and for presenting what have you been done to save this tree. So I will go now to the questions to you. There are some questions that have been raising. So there's one from Oliver Gardi to Andrea and to Naomi. Is soil condition, water availability taken into account for determining ecosystem services with iTree, for example, transpiration?
So there are reports that deal directly with, they are hydrology effects. And so those reports deal directly with the ability of the leaf surface area to evapotranspirate and transpire. What iTree cannot do, and they would really like to be able to do, but have not come up with the equations, is to evaluate soil condition. If you think about urban soil, and if you think about everything that is happening with that often sealed environment that most urban trees are being asked to exist in, the ability to assess soil condition has evaded them. Nobody has been able to come up with established criteria in order to determine what that soil is. Maybe it's not even soil. In many places, construction debris is dumped in as part of the soil substrate. And so how do you determine condition of soil? You extrapolate it from what you know, from evapotranspiration, from transpiration, from the more than that, from the condition of the tree in terms of its leaf surface area.
Thank you. There's another question also from Oliver concerning iTree. Maybe this goes for Andrea. Is it possible to do a simplified assessment with iTree based on the tree cadastre data already available in many cities, for example, tree species, age, DBH, or environment, etc.?
Yes, this is possible, of course. Depends a bit on how precise the datas are and what the last update of this cadastre was. If you use data out of a tree cadastre of a city which contains data from 2016, it's just too old to do precise calculations. But if the datas are actually and good maintained, and everything is everything is well maintained, you can merge these tables and do a simplified assessment. Yes, it's possible.
And to add to that, what we don't consider in the urban environment is we don't use age as a criteria. Mm-hmm. Age is a forest criteria. If you think about trees in their varied landscapes in the urban environment, you have trees appearing as if they are much older than they actually are. So it's more size and condition that drives the assessment criteria than age.
Okay. And an additional question to that is, can it also be done with crown volume that can be extracted from LiDAR?
I would like to say no. And the reason that you cannot, you can use LiDAR as an entry point. But what iTree wants you to do, and in reality, if you are an urban forest manager, what it is your responsibility to do is to go and visit the tree and take the measurements, because part of iTree's accuracy is the condition component. Leaf surface area is critical to ecosystem services. It's what the tree excels at. And in order to really determine what that tree is able to contribute in ecosystem services, you have to do a condition rating. And you cannot do this with LiDAR.
Mm-hmm. Okay. Thank you very much. There's a last question from Ian McDermott. I think that concerns Naomi. He's wondering why the radial trenching was not done before the surface decompaction treatments. Is there a reason for this order, please, or did I misunderstand this? So could you maybe clarify it, why it was done after?
In my own experience, in assessing what was at this site, the soil was so compacted that I wanted to first begin the process of opening up the soil by removing the geotextile. The initial layer of soil was this non-soil installation of stone. Now, to do radial trenching in a stone environment is much more complicated than doing radial trenching in a soil environment. And so I started with the focus of trying to open up the soil by introducing real soil and compost tea to make what was there more workable for the radial trenching component.
Okay, thank you very much.
You're welcome.
So I would like to thank you all, to all participants, for being here today and making this first day of the FF Week a success. There were times where we were more than 25 people. That was nice to see so many that participated. I also want to thank all the referees, Naomi, Andrea, Oliver, and also Michael, that made today's webinar also very interesting. I learned also once more a lot about what is going on in the Swiss context. So I would like to thank you and also Vera for helping me out, Vera Krill for helping me out with the techniques behind. So I would like to thank you, all of you, and I wish you, yeah, guten Appetit, also enjoy your lunch. Thank you.